Hello, my name is Christina Martin and welcome to my iSTEM Strategies project. The focus of my project is to show how computer modeling can be used as a tool in the mathematics classroom to implement an integrative STEM lesson. Before we begin, let's define what integrative STEM education is. Integrative STEM education is defined by Dr. Mark Sanders as the intentional integration of the practices and concepts of math and science with the concepts and practices of technology and engineering education. Sanders also offers that integrative STEM applies a purposeful design inquiry. The purposeful design inquiry model strategically engages students in scientific inquiry and the applications of math within the context of designing or problem solving. A successful integrative STEM lesson intentionally integrates subject area content with the technology and engineering content and practices. A key question for any integrative STEM lesson is how will purposeful integration occur? In this integrative STEM lesson, using computer modeling to enhance student understanding of geometric transformations, purposeful integration will occur between mathematical content, technology content and practices, and engineering content. Students will be using a surface-level understanding of geometric transformations to create a computer program in which the geometric transformations are represented. Students will be scaffolded with the knowledge to complete this lesson, but they will need to work together in cooperative learning teams to solve the problem of creating a program in which all three transformations are performed. The goal of this lesson is to allow students to work with a Cartesian plane to manipulate objects in order to gain a better understanding of how objects move that would not be available to them using traditional classroom teaching methods. This activity is adapted from a similar activity described in the National Council of Teachers of Mathematics journal, Teaching Children Mathematics. This integrative STEM lesson was planned to target both learning goals and skill levels of elementary age students, specifically fourth grade students. However, the computer program Scratch is a very easy program to adapt to specific needs. This strategy could be easily implemented using other subject area content, as well as adapted to meet the specific knowledge and skill level of a wide variety of learners. So what research basis is there for this type of activity? The understanding of geometric concepts plays an important role in all of the STEM discipline areas. Smith and Newman reinforced this idea in their article, Scratch It Out, Enhancing Geometrical Understanding, when they state that integrating geometry concepts with STEM content can promote an understanding of geometry and a coherent view of STEM fields. Many applied mathematical understandings require that students have an underlying understanding of geometry. However, geometric applications can also be found in the other areas of science, technology, and engineering. One thread linking geometry to the other three STEM areas is spatial visualization. In her article, Developing 3D Visualization Skills, Cheryl Sorby highlights the importance of visual thinking, stating that perception and reasoning are both necessary in the thinking process, and that to elevate the reasoning thinking skills above the visual thinking skills is to ignore the way the mind actually works. Sorby highlights a key point of the iSTEM strategy presented here. The use of computer modeling is meant to enhance student understanding by combining both the reasoning thinking skills and the visual thinking skills. Another article, Picture This, Increasing Math and Science Learning by Improving Spatial Skills, goes into greater detail on how spatial skills can be developed in elementary age students. Nora Newcomb, the author of the article, references a study called Project Talent that found that people who had high scores on spatial tests in high school were more likely to major in STEM fields in college and pursue STEM careers. Because spatial skills are tied so closely with the other three STEM areas, Newcomb discusses how the early development of spatial skills may improve achievement in math and science. Many research studies have shown that spatial skills can be improved. Newcomb discusses this fact in her article and explores how a teacher can develop stronger spatial skills. She suggests 3 strategies for improving spatial skills. First, teachers need to understand that spatial thinking is about manipulating shapes and tracking their locations as they move. Secondly, teachers need to reduce anxiety about spatial skills by planning fun activities that students enjoy. Lastly, Newcomb suggests that students participate in activities intentionally designed to develop spatial skills. Traditional practices of teaching geometric transformations would include physical models to manipulate. Students would be able to hold these models and see what happens when they performed a translation, rotation, or reflection. Although many important concepts can be gained through physical manipulation, it restricts the examples that students are exposed to. The use of computer modeling allows students to study and manipulate a wider variety of examples and to explore how these shapes move. The virtual manipulation presented in this iSTEM strategy offers students the opportunity to explore the movement of shapes in much greater detail than would be allowed by traditional teaching methods. The article, Learning and Teaching Geometry with Computers in Elementary and Middle Schools, reinforces this statement by stating that computers offer students the opportunity to see connections between concepts that may not be apparented in the limited understanding that physical models provide. This same article offers another insight into the benefit of using computer modeling. The use of computer modeling offers students the opportunity to work far beyond what would normally be expected through traditional teaching methods. By utilizing the program Scratch, my students will be exposed to the ideas of angle, degree, and the Cartesian plane. Both of these concepts are more advanced than what would normally be taught in fourth grade geometry, and they offer the ability to differentiate learning to meet the needs of every learner. Now let's look at the integrative STEM strategy itself, using Scratch as a tool to enhance the understanding of geometric concepts. The first step in this activity would be building a basic understanding of transformations through the use of physical manipulatives, including learning how to move their body in a translation, rotation, and a reflection. Once students have a basic understanding of transformations, the teacher would introduce the idea of computer modeling. Students would be given direct instruction on how to use the computer program Scratch and given the opportunity to explore the program itself. Students would then be divided into cooperative learning teams and given the task of creating a program in which their sprite would perform each of the transformations. After the activity, students would be asked to reflect on what types of codes were needed to make the sprite perform a certain task and to describe the role of the Cartesian plane in their planning. One key element of this strategy will be assessment. The depth of assessment will prove whether or not this is an effective iSTEM strategy relevant to developing an understanding of geometric transformations. The teacher will assess students based on the depth of understanding exhibited in the explanations and from the successful completion of the Scratch program. Finally, how will buy-in for this iSTEM strategy occur at a local, state, and national level? At the local level, students would be able to share their Scratch programs and explanations to demonstrate the depth of understanding gained through this activity. At the state level, this activity is directly aligned with fourth grade curriculum standards and offers opportunities for differentiation to meet the needs of all learners. At the national level, this activity incorporates the principles and standards for school mathematics and the standards for technological literacy to offer students an opportunity to explore computer programming while deepening their understanding of geometrical concepts.